Okay, now here is going to be a pretty short section where you talk about dividing polynomials, and then we're going to learn the remainder theorem, and we're going to learn factor theorem. They pretty much talk about the same thing. So, okay, now quick review. Do you know how to divide it by this? 98 divided by 5. If we do this division by numbers, if I ask you to do what is 98 divided by 5? Okay, so you put it in this long division form. How many fives in 9? There's only 1, because if it's 2, then it becomes too big. So I'm looking for a number which I put in here, 1 times 5. So 9 minus 5, I get a 4. And then I drop down 8. And then here, how many 5s in 48 is going to be 9, because 5 times 9 is 45. And if you subtract, you get a 3. And that's it, okay, because there's nothing under the decimal. So 98, what are you going to write here? Is 98 divided by 5. The answer is 19 and 3/5. Isn't it? Okay, so very similar. I ask you to do that for this. 5x cubed plus 6x plus 8. Okay, and divided by x plus 2. How can you do that? Very similar to this. We're going to put this in a long division form. So it's a 5x cubed. Okay, pay attention to here. There's no square term. When there's no square term, or the square term is missing, in another word, that coefficient of the square term is a 0, we leave something blank. We have to give some space for the square term. And then we're going to put plus 6x and then plus 8. Okay, so be very careful here. And then here I'm going to put x plus 2. Now, very similar. Can you find how many x plus 2 in the cube term? Which means you're looking for something multiplied by x. We only care about the first term. Multiply by x, you get a 5x cubed. What would that be? That would be 5x squared. So I put that on the top of the square term. So 5x squared. Okay. And then I use 5x squared multiplied by x. I get a 5x cubed. And then multiply by 2, I get a 10x squared. Now you see how I get this and this term. Then I do minus. This minus that is a 0. I did that on purpose. It has to be 0, okay? But the next term, here is nothing or 0. Minus this guy, I get a negative 10x squared. And then I drop down the next term. Okay, next, I'm looking for something here that multiply by x to get negative 10x squared. So that's going to be negative 10x. Is that right? So this one times x, I have a negative 10x squared. Agree? What about the next term? Negative 10x times 2. So I get a negative 20x. All right. And then I do minus. This minus that is gone. Here, I just put here. Just show that what I'm doing. Okay, I do minus. And this 6x minus 20x, which means a plus 20x. So I get a 26x. And then I drop down the next term, 8. Okay, now the last thing, I need to find a number here, find something here, multiply by x to get a 26x. So there will be 26. So that's 20, this times that, which is 26x, and 26 times 2, I get a 52. Okay, and then I do subtraction. 26x minus 26x, I'm super happy it's gone. 8 minus 52, I get a negative 44. All right, so when you do that, you're going to write your answer like this. 5x squared minus 10x plus 26 minus 44 over x plus 2. It's very similar to this, right? So the remainder here is negative 44 I put on top, and this x plus 2 I leave that in the denominator because that's here. This is how you use the long division to do the to work on this to find the quotient and the remainder of this polynomial operation. Okay, all right, so next, the remainder theorem. Remainder. Theorem. The remainder theorem says if f of x, if I use this, I divide it by x minus c, I have the quotient, and I have an r. Okay, if this is true, then f of c will be r. Okay, this is very easy because just like the one we have earlier, if this divided by x plus 2, then you have a remainder is negative 44, then f of c will be r. So which means f of, what is the c here? C should be negative 2. F of negative 2 will be negative 44. That's what it says. Okay? And if you plug in x, if you substitute x by c, see, here is a c, c minus a c is nothing, so the whole part becomes nothing or 0, and you have only r. So this is the remainder theorem. I can prove it because I have this f of x equals 5x cubed plus 6x plus 8. Okay, so that is x plus 2 multiplied by, remember what's the quotient function? 5x squared minus 10x plus 26, and at the end I have a negative 44. You see? Okay, so I have this, therefore I have f of, remember my c is negative 2, should be negative 44. Is that right? Let's see. This is f of x, so f of negative 2 will be 5 times the negative 2 cubed plus 6 negative 2 plus 8. Okay, so negative 2 cubed is negative 8, 2 by 2 by 2. So negative 8 times 5 is negative 40. And this is negative 12. And this is a plus 8. So negative 40 minus minus 12, which is negative 52, plus that. So I do get negative 44. Duh. I got it. Okay, so this is called the remainder theorem. And the other theorem we're going to learn is called a factor theorem. Factor theorem says this: f of x, a polynomial. Okay, so if f of c equals 0, then x minus c is a factor of f of x. Okay. If x minus c is a factor of f of x, then f of c equals 0. So they pretty much talk about the same thing. Or in another word, if c is a 0 of f of x, then f of x is divisible by x minus c. They all talk about the same thing. In this case, there's no remainder involved. Did you see that? It's a factor, so no remainder. And this, if f of x equals x minus c times q, the quotient, polynomial plus r, if r is 0, then here's a 0. That means f of c equals 0. So c is a factor. So this one, this factor theorem, is a special case of this remainder theorem. That's the special case, means r, or the remainder, is 0. Okay, so it sounds complicated, but it's not that hard. So if I tell you that 3 is a 0 of f of x, which is 2x cubed minus 3x squared minus 11x plus 6. Then I ask you to solve the equation. The equation is left equals right, okay? So that means the equation 2x cubed minus 3x squared minus 11x plus 6 equals 0. I ask you to solve this equation, which means please find me all the solutions or all the x values that will make this guy to be 0. In another word, I tell you 3 is a 0. Can you find other zeros? All right, now we're going to do, because 3 is a 0, so that means this f of x has a factor of x minus 3. Isn't it? That's by this factor theorem. So let's try. Okay, so I'm going to divide it by x minus 3. 2x cubed minus 3x squared minus 11x plus 6. Long division, you have to know this, okay? So I'm looking for something multiplied by x to get a 2x cubed. So that will be 2x squared. You see, I write on the top of the square term. So this times that, I get a 2x cubed, and then I go minus 6x squared. Okay. Do minus 2x cubed minus 2x cubed is nothing, and negative 3 minus negative 6, I get a negative 3 plus 6, so I have 3x squared. And then drop down this. Next one, I need to find something that multiply by x to get a 3x squared, which is plus 3x. Okay, so that's a 3x squared minus 9x. All right, now the square term get canceled when you do minus, and then negative 11 minus negative 9 means a plus 9. So I get a negative 2x, and then drop down this. So I'm looking for something multiplied by x to get that. I get a negative 2. So negative 2x plus 6. When I subtract, I get a 0. So it is divisible. Therefore, I'm going to write 2x cubed minus 3x squared minus 11x plus 6. That is x minus 3 times 2, the quotient function, quotient polynomial, plus 3x minus 2. Well, I don't have the formula to solve a cubic function, but I do have the formula to solve the quadratic function. This is okay because I leave it there. X minus 3 is already there. Can you factor this, or can you find the solution for that? There are two ways to do it. One is by factor. I keep this x minus 3. Can you factor this? Because here is 2x squared, so it's either x and 2x. And I'm looking for two numbers, and this number times 2, this number times 1. Add them up, you should get a positive 3. And this number times this number to get negative 2. You can try a little bit. I don't know how good you are with the factoring. Factoring a quadratic polynomial, or if you're not good, then you probably need to go back to some, I don't know, not in this class, but I think in algebra 2 to factor. So what I will have is going to be x plus 2 and 2x minus 1. So when I factor this, I get that, okay? So if I want to solve this equals 0, which means I'm going to solve this guy equals 0, so you can see if A, B, C, they multiply together to get a 0, so either A is 0 or B is 0 or C is 0. So which means either x equals 3 equals 0, so that means x is 3, or x plus 2 equals 0, which means negative 2, And the last one, 2x minus 1 equals 0. I just do this really quick. I have plus 1 on both sides, then divided by 2. So I get a 1/2. That is my solution. Okay. The other way, you already know x minus 3, so you already have one solution. The other way is to use quadratic formula, a, b, c. So in order to solve 2x squared plus 3x minus 2 equals 0, I get my a is 2, b is 3, and my c is -2. And the quadratic formula x will be 2a negative b plus minus. I think eventually you're going to be very good at this. You should know that. If not, then please, you might want to take a little special note as your cheat sheet when you do your homework or quiz or exam. So that will be, okay, so 2a, which is 2 by 2, which is 4. And the negative b is -3, plus minus the square root of b squared, which is 9, okay, minus 4ac. So that's a 4 times 2 times -2. Okay, so that is -3 plus minus, let's see what's here. 4 times 2 times -2, that's 8, 16, and a positive. So that's 9 plus 16 inside, and 4. So it's -3 plus minus, here is 9 and 16, that's 25. Square root of that is 5/4, right? So let's do plus first and do second, we do negative, we do minus. So x could be either, when you do plus, -3 plus 5, I get a positive 2. So 2/4, that is 1/2. And the other one, when you do minus, -3 minus 5, which is -8, divided by that, you get a -2. You see? You get exactly the same solution as using the factoring method. Okay, so this is how you use the factor theorem to solve a equation. Okay, I told you it's a short one, but it does require something that you learned earlier, especially this quadratic. If you don't know how to factor a quadratic polynomial, you can, or to solve this quadratic equation, this is universal. Okay, if you don't know how to factor, use this method. That always works.